So just as a reminder, as we look at example 1 here, the slope in your equation, as long as it's solved for y, is the number with the x, and then your y-intercept is the number by itself without the x. So in your first equation, since it is solved for y, we've got y equals 3x plus 3, so we're going to start at your y-intercept of positive 3, and positive 3 over 1 slope. So we're going to go up and right. So up 3 over 1. The more points you can plot, the better, since we are looking for an exact spot where these two equations are going to intersect. And then you guys can go ahead and graph the second line. So y equals negative x plus 7. So that slope is really just negative 1 over 1. So your y-intercept is positive 7. And slope down 1 over 1. So right there will be our point of intersection, or our solution. So that's going to be 1, 2, 3, 4, 5, 6. 1, 6. So remember, you guys can always substitute your ordered pair back into your solutions to check them. I just wouldn't ever mandate that you guys check them, but it's never a bad idea to make sure that the point you found is actually correct. So if your equation is not solved for y, you would need to do that. So like in example number 2, this guy does need solved for y. So if I just come over here and rewrite it real quick, and I'm going to put 1s with my x's and y's. We're trying to get the y by itself, so we need to subtract that 1x over 1y equals 6 minus 1x. And you can divide everything by 1 if you would like, but that won't change anything. So 6 minus 1x. So your y-intercept is going to be positive 6. Slope is negative 1 over 1. So down and right. Then we'll plot our other line, which is solved for y. There's just no y-intercept there. So the y-intercept is going to be 0. Slope is positive 2. So up 2 over 1. Again, the more points you can do, the better. Just to make sure we're precise in getting that correct point of intersection, that solution, to both of your equations. So that guy right there, which looks like 2, 4. So we're just looking for an ordered pair that if you guys substituted back into your equations would make both of those equations true. It's the only shared point that both of your lines or both of your equations have. So let's look at example 4. So same thing, we have to solve these for your y also. So I'm just going to rewrite them. So 3x minus 2y equals 6. So let's move your x term to the other side. So negative 2y equals 6 minus 3x, and then divide everything by negative 2. So we've got y equals 6 divided by -2, -3, negative divided by negative, positive, keep that as a fraction, that's your slope. 3/2 x. And then let's solve your other equation for y. So 6x minus 4y equals 4. So move that x term over. Remember, don't actually combine them. So negative 4y equals 4 minus 6x. Divide every term by that negative 4. So we get y equals 4 divided by -4, -1, negative divided by negative again, positive 6/4 x. So let's graph them both. So I'll graph this green one here first. So y-intercept of -1, positive 6/4 slope. So up 6 over 4. Go the other way. Draw a nice line. And then graph your other line. Y-intercept of -3. Positive 3/2 slope, so up 3 over 2. Up 3. And hopefully you guys are noticing that it is not intersecting. So this is one of those situations where we have parallel lines. So they are never going to intersect. They're going to run side by side together forever. So there's no ordered pair that is ever going to make both of these equations true. So graphing parallel lines, never intersecting. But there's no ordered pair that these two lines are ever going to share. So this is just one of those odd ones that's going to be no solution.